there is another example that I came across, okay, and we will try to solve it based on the characteristics of the population, that the variances for the first population and the second population is equal. Okay, so the variances are equal, but it is still unknown. Okay, we will do this case actually. Okay, so the question says that a doctor, actually a research team, is investigating the mean difference between the systolic blood pressure. Okay, so the parameter over here is the mean systolic blood pressure BP, okay, between men and women. Okay, now men has a different population and women has a different population, and both of the populations are independent of each other. Okay, and similarly the samples are also independent. Okay, the first sample is taken for men and the sample size N1 is equal to 1623. Okay, and the mean blood pressure, systolic blood pressure for men is equal to 128.3. Okay, now the standard deviation, okay, for the sample, these samples 1623 men is 17.5. Okay, now the other sample that is taken, that has a sample size for women N2 is 1911 women. Okay, and the mean systolic blood pressure for women is 126.5 with a standard deviation of 20.1. Now the research team is investigation whether these two samples are populations, the population means for the groups, the men and women, for the systolic BP blood pressure, they are either same or they differ significantly. So for that we need to calculate the confidence interval for x1 minus x2. Okay, so we know that the population variances are equal, okay, but still unknown. So when we don't have any population, what we call it, the population standard deviations, okay, then we use the t table. Okay, if the population standard deviations are given to us and we know that, then we use the z distribution. Okay, that is also a difference that you must know. Okay, the first thing is the sample size. Okay, now the sample size over here is quite large, it is not less than 30, but we still use t table. The reason to use t table is this thing, that we don't know about the population standard deviation. So if you don't know about the population standard deviation, then we use the t table. Okay, so using the t table and finding the pooled variance for the samples simultaneously, and then putting it in the formula to find the mean difference actually. So we know that the confidence interval is equal to x1 minus x2 bar plus minus t alpha by 2 and 1 plus n2 minus 2 multiplied by sp into under the root 1 over n1 plus 1 over n2. Okay, now we have this value, we need to find this from the t table, and we need to find this and this. So first of all, finding the pooled variance, which is equal to the square root of n1 minus 1 into s1 square plus n2 minus 1 into s2 square divided by n1 plus n2 minus 2. So the pooled variance is equal to n1 is 1 6 and 2 3. So 1 6 2 3 minus 1 will give us 1 6 2 2 into s1 square. S1 is 17.5, so 17.5 square multiplied by plus 1911 minus 1, it will give us 1910 into the standard deviation for the women are 20.1 square divided by 1623 plus 1911 minus 2. Okay, simplifying this term will give us, let's find the square for these twos and multiply it with it, so we find the exact value. Okay, 17.5 square will give us a value of 306.25 and 20.1 whole square, it will give us a value something around about 400 something. Let us calculate it. $404. Okay, so 400, writing it 404.01, so it can be rounded to 404. Okay, and 1623 plus 1911 minus 2, so it will give us 1621 plus 1911. So doing it over here, 1621 plus 1911, it will give us 2 3 15 1 3 5 3 2. Okay, I subtracted these two from 1623. Okay, so let's multiply and add these and divide by 3532. Okay, so SP will give us okay, so the second term 1910 when multiplied by 404, it gives us a value of 771659.1. okay, and the other one 1622 multiply by 1622 multiply by 306.25, it will give us 496,737.5 and divided by 3532. So let's add these two giants. Okay, so let's add it with the 771659.1. it will give us a total value of 1268396.6 and divided by 3532. So let's divide it by 3532 divided by 3532. So we get a value of under the root 359.11. okay, take the square root of it, we get a value of SP is equal to 18.95, which can be rounded to 19 actually. Okay, so now we have the pooled variance. Let's calculate the t value and the multiplier of the pooled variance. Let's first calculate the multiplier of the pooled variance. Okay, so 1 over n1 plus 1 over n2, it will give us 1 divided by n1 is 1623 plus 1 divided by 1 9 and 1 1. Okay, now let's calculate this. 1 divided by 1 6 2 3. Okay, so it will give us a 6.16 into 10 raised to the power minus 4 plus, let's calculate the other one also, 1 divided by 1911. It will give us 5.23 into 10 to the power 5.23 into 10 raised to the power minus 4. Okay, now adding both these values and taking the square root. Okay, so we can write it as 0.00006, okay, plus 0.0000 and 616. So it gives us a value of 5.84 into 10 raised to the power minus 4, and taking the under root of it, so it will give us a value of 0.024. So this is the value of the multiplier. Okay, this factor. Okay, it will yield this value. Okay, now we have this. Let's calculate this from the t table. Okay, and we also have these two values, so we can find the confidence interval. So alpha is equal to 0.05, as we want to find 95% confidence interval. Okay, so alpha is equal to 1 minus p, implies that 1 minus 0.95 is equal to 0.05. Okay, this is the value of alpha, and alpha by 2 is equal to 0.025. Okay, so t 0.025 comma and 1 plus n2 minus 2. Okay, now n1 plus n2 minus 2, it will give us 3532. Okay, 1623 plus 1911 minus 2, it will give us 3532. Okay, so this is the value that we want to find from the t table. Okay, so let's find the value. So from t table, actually the limit is the sample difference, the degree of freedom, it must be less than or equal to 1000 and above 1000, and for above 1000 it is actually same. Okay, so for 1000 and 0.025, the value that we are getting is 1.962. Okay, so t 0.025 and 3532 is equal to 1.962. Okay, we will put this value into the confidence interval is equal to x1 bar minus x2 bar. So x1 bar is equal to 128.3 minus x2 bar is 126.5 plus minus. Okay, now t alpha by 2n and 1 plus n2 minus 2, this value is equal to 1.962 multiplied by sp, the pooled variance. The pooled variance for both samples simultaneously is equal to 18.95. Okay, multiplied by the pooled variance multiplier, which is under the root 1 divided by n1 plus 1 divided by n2, and that gave us a value of 0.0242. Okay, now putting all these values, we get the final value as this will give us a value of, let's calculate it. So okay, so 128 minus 126.5, 128.3 minus 126.5 it gives us 1.8, positive 1.8 plus minus. Now we will get the 1962 multiplied by 1.962 multiplied by 18.95 multiplied by 0.242. Okay, 0.0242 actually. 0.0242. 0242. It gives us a value of 0.899 or 0.9. Okay, so plus minus 0.9. Okay, so now the confidence interval is equal to 1.8 minus 0.9 and 1.8 plus 0.9. So this will give us a value of 0.9 and this will give a value of 2.7. Okay, now we see that in this confidence interval actually the value starts from positive and on the other side it is also positive. Okay, it means that the difference is positive, and both the means actually, the blood pressure means for men and women, they differ significantly. So inference is that there is 95% chance that the blood pressure for men and women differ significantly for both the populations. Okay, so that is how we give the inferences and all. Okay, we have a third case over here, which is when we have two samples, two populations, and two samples are taken randomly from both the samples, and both the samples taken are independent from each other, and as well as the populations are independent of each other, but the population variances, okay, we have two populations, so population variance of population 1 and the variance of the population 2 are unknown. Okay, we don't know about the population variances, and both are not equal to each other. Okay, both are unknown and not equal to each other. Okay, so whenever we don't know about the population variance or population standard variation, then we use the t table. Okay, and the x1 minus x2 bar plus minus the confidence interval, actually it will be equal to x1 bar minus x2 bar, which are the mean for the samples taken from both the populations, and t alpha by 2 comma v. Now v here is the degree of freedom, okay, multiplied by the standard deviation 1 square divided by n1 plus s2 square divided by n2. Okay, so this will be then the formula to be used. Okay, when they are equal, then we will use the pooled sample variance. Okay, but if they are not equal, then they are unknown and not equal, then we will use this formula. So you need to know the difference between the conditions that are given to you and how to interpret those and use the formula against that. Okay, that you need to know. Okay, this thing is actually crucial to understand and know. Now the degree of freedom v, actually it is equal to s1 square divided by n1 plus s2 square divided by n2 whole square divided by 1 divided by n1 minus 1 into s1 square divided by n1 whole square plus 1 divided by n2 minus 1 into s2 square divided by n2 whole square. Okay, this is the degree of freedom, and it must be rounded to nearest integer, because we cannot take the degree of freedom in some decimals or in fraction form. We take it in some integer form. Okay, so now I will try to find an example regarding this one and solve it for you to understand the process. Okay, we have an example. A psychologist actually is interested in comparing the driving behavior of male and females. Okay, and the data that he collected is the mean speed for example, the first sample is for men, and the sample size he collected from 34 drivers. Okay, so 34 drivers, men drivers, were in this sample space. Okay, so n1 is equal to 34, and the mean speed for the men was 105.5 kilometer per hour. Okay, and n1, the sample size, was 34, and the standard deviation for this sample was 20.1 kilometer per hour. Okay, and the other group was for female drivers, and the sample size for female drivers n2 was 29 female drivers. Okay, so sample size n2 is 29, and the mean speed that he calculated was 90.9 kilometers an hour. Okay, and the standard deviation for this sample was 12.2 kilometer per hour. Okay, now we have these data points. Okay, and it also says that both the population have different variances and are unknown to us. Okay, so it means that sigma 1 square is not equal to sigma 2 squares, and both are unknown. Okay, so when this condition occurs, we are bound to use this case. Okay, because we don't have any population variances. Okay, and both the population variances are not equal. Okay, so we will use this kind of case and calculate the confidence interval, which is equal to x1 minus x2 bar plus minus t alpha by 2 into v. This v is the degree of freedom, multiplied by under the root s1 square divided by n1 plus s2 square divided by n2. Now we are interested in finding the degree of freedom first. Okay, so let's calculate the degree of freedom over here. So the degree of freedom has a formula of s1 square divided by n1 plus s2 square divided by n2 whole square divided by 1 divided by n1 minus 1 into s1 square divided by n1 whole square, plus similarly on the other side n2 minus 1 into s2 square divided by n2 whole square. Okay, so first of all, doing the numerator work. Okay, so s1 square is equal to 20.1 square. Okay, so it will give us about 4.4.01. Okay, now s2 square is equal to 12.2 whole square, and it will give us a value of 12 square will give 144, but the 2 square will give us 4, so it will be 144.4 or something. Let's calculate it. 148.84 is the value that we get over here. Okay, now let's find the putting these values into this numerator part. We get 404.01 divided by n1, which is 34, plus sample size is 29, we get whole square. So let's calculate this and make the square of it, and it is divided by 1 divided by 34 minus 1 will give us 1 by 33 into s1 square is 404.01 divided by n1, which is 34 whole square, plus 1 divided by 28 into 148.84 divided by n2 is 29 whole square. Okay, so let's do the calculations. So 404 divided by 34, it will give us 11.88. Okay, so let's substitute the value over here. It is 11.88 plus, let's get the value of the other one. The other one will give us a value of 5.132, and we will take the whole square of it. Okay, divided by 1 divided by 33 into, this is already found, which is 11.88, so taking square of it, plus 1 over 28 multiply by, this is also already found, which is 5.132 whole square. Okay, so now let's calculate the first part over here. It will give us 11 plus 5, it will give us 16, and 88 plus 132, it will give us about 17 point something. Okay, whole square divided by, okay, so 17.01 whole square divided by 11.88 whole square and divided by 33. So let's calculate it. This 17.01 whole square, it will give us 289.4, and let's find the denominator and make the calculations. This 11.88 whole square, it will give us 141.13. So 141.13 divided by 33 plus, let's calculate this square and divide by 28. So 5.132 square, 5.132 multiply by 5.132, so it is squared. The square gives us a value of 26.337 divided by 28. So let's divide it by 28 to get the final value. Okay, so we get 289.4 divided by this will give us a value of 0.94, and let's calculate this. 141.13 divided by 33. It will give us a value of 4.276. 4.276. Okay, now 289 divided by 4.276 plus, let's add the other value with that 0.94 added to 4.276. It will give us 5.216. Okay, so 289.4 divided by 5.2166. Okay, so 289.4 divided by 5.21666. Okay, it will give us 55.47, which is equal to 55, round it to 55. Okay, so the degree of freedom V is equal to 55. Now that we found the degree of freedom as 55, okay, the only thing left over here is to find the value of t from the t table and the multiplier of the t table, which is s1 square divided by n1 plus s2 square divided by n2 whole square root. Okay, so let's find that also. Applies that, and that the root s1 square divided by n1 plus s2 square divided by n2 is equal to, under the root, okay, s1 square gave us a value of 404.01, okay, divided by n1, okay, which is actually 34, plus s2 square gave us a value of 148.84, and divided by n2 is 29. Okay, so under the root of we already have found it over here, so let's get the value. This will give us a value of 17.01. so under the root of 17.01 will give us 17.01 under the root 4.124. okay, it is equal to 4.124. so this is the value of the multiplier. Okay, now finding the value of the t of 0.025 and 55, because we found the degree of freedom as 55. Let's find the value from the t table. Okay, so the degree of freedom over here is 55, and we see that above 50 to 60 the values remain actually about same. Okay, so we can either take 50 or 60. Let's say we take like 50. Okay, now for 50 and the degree of freedom, the value 0.025, and this is 0.025, and the value for the 50 is 2.009. okay, 2.009 is the value against 50 and 0.025. okay, 2.009. so let's take that value. Okay, this is 2.009. okay, or 2.01, we can round it to 2.01. okay, now putting the values we get the final solution. Okay, x1 bar minus x2 bar, actually x1 bar minus x2 bar is equal to 105.5 minus 90.9 plus minus the t value, which is 2.01 multiplied by the multiplier, this one, which we got 4.124. so you get the value of 105.5 minus 90.9, so it will give us about 14.4. okay, let's calculate it. Okay, this gives us 14.6 plus minus 2.01 into 4.124. 2.01 multiplied by 4.124, it gives us 8.29, approximately 8.29. okay, so we can say that 14.6 minus 8.29 and 14.6 plus 8.29. So the value that we get for the confidence interval is equal to 14.6 minus 8.29 gave us a value of 6.31, and 14.6 when added to 8.29, it gives a value of 22.9 actually. So here both the values actually are positive. It starts from positive and ends on positive. The range is all between positive, so it means that the behavior is actually significantly different. They are not same drivers by behavior. Men and women are significantly different in driving. Okay, thank you. Okay, so in this video actually we will be doing the estimation of proportions. Okay, we did the estimation of the mean, the standard deviations and all that. So now we will do the estimation of proportions. So by example actually we can say the proportion is the percentages or rates or probabilities actually. Okay, for example the probability that for example the when the COVID was happening, there were a group of people who were at high risk of getting a heart attack or any organ failure with the getting the COVID. Okay, so the scientists discovered that there is a specific blood type or blood group that is at high risk with the that organ failure or anything like that happens with the COVID. So if we take that case and we want to find that what proportion of people in their blood group are actually at risk of heart attack when they get COVID, this is a kind of the estimation of proportion problem. Okay, or for example we are interested in finding the proportion of people that get for example some disease using a product or using some medicine. Okay, for example few medicine have some side effects. Okay, so the proportion of people in the sample or in the population that actually gets that disease or that condition after they use that medicine or vaccine. Okay, so this is the estimation of the proportion. Okay, so rates, percentages, probabilities are kind of proportions, or we want to find the defectives in the large shipment of some product. Okay, that is also proportion because it involves percentage. Okay, so anything that involves percentages or rates, okay, these are the estimation of proportion problems. Okay, so in this this portion, this video, we will be doing the estimation of the proportional problems. Okay, so the parameter over here is a binomial parameter theta, that is of consideration, or that is in focus over here. Okay, and we say that we assume that for the large n, when the sample size is sufficiently large, then this binomial distribution actually is approximated. It means that it is quite equal to the normal distribution. Okay, it means that for large n, the qualities of this distribution is equal to the qualities of the normal distribution, because most of the time we find it for the normal distribution. So if the sample size is large, then this binomial distribution actually transforms into the normal distribution, or it acquires the properties of the normal distribution. Normal distribution, we write it as standard deviation, the sigma square, and mean. Okay, this is the representation of the normal distribution. Okay, and the z value for the normal distribution is equal to x bar minus mu divided by sigma divided by under the root n. Okay, this is the population mean, this is the sample mean, this is the population standard deviation, and this is the sample size n. Okay, so this is the z value. Here z is equal to x minus n theta divided by n theta into 1 minus theta. Okay, so if n is sufficiently large, okay, then this actually is equal to, or we can say that approximately equivalent to the upper one, the normal distribution value. Okay, so the theorem says that if x is a binomial distribution, okay, if x is a binomial random variable RV, when I write RV, it means that it is random variable, okay, with parameters n and theta, and n is large, and the estimated theta is equal to x by n, then the confidence interval, or the estimated value for this theta bar or theta cap is equal to the theta is equal to theta bar or cap minus z alpha by 2 into theta cap into 1 minus theta cap divided by n less than theta and theta cap plus z alpha by 2 multiply by theta cap into 1 minus theta cap divided by n. It is just like we write the confidence interval okay, for theta. So this is the confidence interval for theta, and this is the population parameter, okay, and theta bar is the estimated value, okay. So this is the estimated value plus minus z alpha by 2 into estimated theta 1 minus estimated theta divided by n. So this is kind of short form of it, okay. Now we will solve a problem on this so that you know how it is used, okay. So getting to the example and explaining the whole procedure, okay. So example says that in a random sample, okay, of 400 persons, okay, the sample size n is equal to 400, okay, the total people involved is equal to 400. So it says that in a random sample of 400 persons, so 136 of 400 person given the flu vaccine experienced some discomfort, okay. So it means that the proportion 136 out of 400 experienced discomfort with the vaccine, okay. So 400 people were given the vaccine, and out of those 400, 136 were experiencing that discomfort. So the proportion of people with discomfort is equal to 136 by 400, okay. This is the proportion, and it is 0.34, that is 34% of the people, okay. So we know that the theta bar is equal to x divided by n, and x is this 136, okay, 136, and n is 400. So we get theta bar is equal to 0.34, which is the same value that we get here. So theta bar is the proportion of people with discomfort, okay. Now we have theta bar is equal to 0.34, okay. So the other thing that we need in this scenario is n, and n is 400, that is given to us, and z alpha by 2, okay. So we want to construct a 95% confidence interval, okay. So for 95% confidence interval, alpha is equal to 1 minus p, and 1 minus 0.95 is equal to 0.05, and z alpha by 2 is equal to z 0.05 divided by 2, and it becomes 0.025, and this value is 1.96 from the z table, or online you can see it or calculate it, okay. So now putting the z alpha by 2 as 1.96, theta bar or cap is equal to 0.34, and is equal to 400. We have all the things that we need for to construct the 95% confidence interval for the theta, and it is equal to theta bar plus minus z alpha by 2 into theta bar into 1 minus theta bar divided by n. So we need to find this part of the problem. So we have the theta bar is equal to 0.34, so 0.34 into 1 minus 0.34 divided by 400 under the root, it is equal to 0.34 into 1 minus 0.34 will give us 0.66 divided by 400. So calculating the upper portion of it, the numerator part, it will give us let me calculate 0.34 0.34 multiplied by 0.66, it gives us 0.2244 divided by 400 under the root. So dividing it by 400, it gives us a value of 0.000561. Okay, and taking the square root of it get us a value of 0.023. okay, so this is the value of this factor. Okay, now putting the values, so 95% CI is equal to theta bar is equal to 0.34 plus minus z of alpha by 2 is actually 1.96 into 0.023. So we get 0.34 minus, let's multiply that value with the 0.023. So 0.023 multiplied by 1.96, we get 0.046. So 0.34 minus 0.046 and 0.34 plus 0.046. So 95% CI is equal to it is equal to 0.29. okay, and the other side is equal to 0.386. okay, so it says that it is like 95% chances that the theta lies between 0.29 and 0.386, or the people that are getting the disease or that are getting the discomfort from the vaccine lies between 29% and 38.6%. okay, so it is 29% to 38.6%. this is the range in which the proportion of population actually lies which receive discomfort from vaccine. okay, so that is how we do the proportions. okay, I will try to have like some more problems regarding the proportions, and we will also explore it further, okay, in the next lecture. okay, thank you.